Aegis, Advanced Ground Information Systems, developers of multi-domain data link software. Aegis's MDDL enables a worldwide, multinational integrated C5 ISR system with the ability to process data for more than 10,000 classified and unclassified sensors. There is a need for our operational forces and allies to receive integrated data from the various Space Force satellites. This requires a vast amount of software processing. Aegis is able to achieve this with a minimum of hardware. This video demonstrates our ability to meet this need even on a smartphone. By using the cloud or on-premise servers, Aegis's complete C5 ISR system enables massive sensor feed tracking and translation of the data from classified and unclassified satellite sources into a common C4I MDDL data link format, and then reformatting the data into the appropriate tactical data links. Aegis enables an integrated, common operational picture between all interfacing C5 ISR systems without any modification to the aircraft, ship, or vehicle systems or changes to their existing data link standards. Here we see 10,000 plus real-time unclassified data reports displayed on our MDDL system, including real-time aircraft and ship sensor feeds from all over the world. When connected to a US or NATO C5 ISR system, this data would automatically be transformed and transmitted into the classified data link formats. In order to operate in a high-threat environment, Aegis's MDDL system operates from either rapidly deployed fixed locations or on the move. Because of its capacity, this system can also process classified sensor reports from various air, ground, and sea US and NATO C5 ISR systems and allow them to communicate and exchange data with each other on a worldwide basis. Here we can hook AIS tracks to get detailed info like vessel name, type, call sign, destination, MIMSI and IMO designations, as well as range and bearing, length, width, and draft. Here we can hook an air track to get the aircraft's call sign, heading, speed, and altitude. Aegis's MDDL system permits the establishment of groups, which can limit the information exchange to the type of data of interest or the need to know. Through the LifeRing-enabled command center, we now have a scalable, integrated C4I air, ground, and sea COP. To try the unclassified portion of our revolutionary C5 ISR system right now, go to www.liferingmilitary.com. Our classified app is available to those who qualify for this system. For more information on our LifeRing products, please visit our website at www.aegisinc.com. Aegis, Advanced Ground Information Systems, makers of a multi-domain data link software. This complete C5 ISR system enables massive sensor feed tracking and translation of data from unclassified and classified sources to create a common operational picture of the air, ground, and sea. Here we see 3,000 plus real-time unclassified sensor reports displaying real-time aircraft, ship, and ELINT sensor feeds focused in the South China Sea. The system supports a global COP and has the capacity to display 100,000 sensor reports. We can get detail on each of these sensor reports by hooking the symbol associated with it. We can hook an air track to get the aircraft's call sign, heading, speed and altitude, as well as range and bearing. When available, I can also get a representative image of the type of craft. I know this plane is an Airbus A321, and I get a picture of what an Airbus A321 looks like. Here we can hook a C-track to get the detailed info like vessel name, type, call sign, destination, MIMSI and IMO designations, as well as a range and bearing, length, width, and draft. Again, I can get a representative image of the type of craft. The bulk of the symbols you're seeing on the map is ELINT data received from an unclassified satellite source. Here we can hook a radio symbol. In addition to the location, we see the signal is VHF and we get the frequency and channel. I can hook another one and I can see that the signal is L-band. I can also hook a radar symbol. Again, I get the location as well as the signal, X-band. I also get the frequency as well as the repetition frequency and length of the pulse. I can also get ship symbols as ELINT data, so I know that a VHF signal emanated from this vessel. Through the LifeRing-enabled command center, we now have a scalable, integrated C5 ISR worldwide common operational picture of the air, ground, and sea, integrating markers, ship traffic data, air traffic data, ELINT data, and more, and the ability to display 10,000 plus sensor reports and thousands of users simultaneously. If connected to US or NATO C5 ISR systems, This data will automatically be transformed into the classified data links formats. For more information on our LifeRing products, please visit our website at www.aegisinc.com. Iridium, a low Earth orbit, global coverage satellite communications company, is teamed with Aegis, a software company specializing in CJAD, C2, C5 ISR common operational picture software and terrestrial and satellite sensor processing, along with McHugh Inc., a leading provider of advanced technology, deep battlespace, situational awareness sensors. This video will demonstrate how the team is able to provide a DoD-mandated CJAD C2 battle management system and worldwide real-time McHugh sensor detections using our existing and proven capability to meet DoD requirements. Together, this team organized a global demonstration using Iridium Communications Network, McHugh Worldwide Sensors, and Aegis's CJAD C2 system to process the data and to make it available to interfacing C5 ISR systems. This video shows different types of sensor detections occurring at various worldwide U.S. military sites. The sensor reports include information from McHugh Ranger ground sensors, McHugh Owl intelligent cameras, and the McHugh RScene micro radar. Also included is imagery sent over the Iridium via the McHugh Connect satellite modem. All of this information was communicated via Iridium to an Internet Protocol cloud server and processed and displayed on the Aegis C5 ISR operator display. The video captures data from the McHugh sensors at 5 worldwide military bases: Peterson Air Force Base in Colorado, Nellis Air Force Base in Nevada, Dyess Air Force Base in Texas, the Marines 29 Palms Base in California, the Marines Forward Deployed Recon Group in Okinawa, Japan, Camp Humphreys at Pyeongtaek, South Korea, and from McHugh facilities in Fredericksburg and Milford, Virginia. The video further demonstrates how Iridium's capability to provide global coverage of every spot on Earth enables real-time, low-latency CJAD C2 information simultaneously to battle management multi-domain centers located anywhere in the world that are supporting Army, Navy, Air Force, Marine Corps, Space Command, NATO partner countries, and Indo-Pacific partner countries' combined military operations. This new worldwide CJAD C2 battle management architecture technology is in place and ready for operations. The Iridium Global Low Earth Orbit Communications constellation continuously covers every inch of the globe, including the Arctic and Antarctic. Furthermore, the Iridium constellation provides many security protection features and is virtually impossible to jam or physically attack. Using Iridium Communications, Aegis and McHugh have created an advanced CJAD C2 system to monitor hostile activities in any military worldwide area and provide the information via Iridium in less than a minute to command centers and personnel with smartphones in the field. The team has consolidated all of the critical military communications, hostile activity monitoring, and battle management into a global, multi-nation capability for the U.S. and our partner countries.
Aegis, Advanced Ground Information Systems, makers of LifeRing software. LifeRing puts a command operations center in the palm of your hand.
In addition to providing a common operational picture, LifeRing performs real-time processing of vast amounts of sensor data. This video shows LifeRing performing both single radar and multiple sensor tracking. Here we can see 5 radar sites providing data. The video playback of a real operation shows the radar locations along with other symbols and the raw radar sensor data called plots being received from each of the 5 radars every 10 seconds. Hundreds of plots are received each 10 seconds from each of the 5 radars. The raw plot data is first processed to discard numerous birds, weather, waves, and mountaintops. The resulting raw data, which consists of only range and bearing location information from the sensor, is then subject to an Aegis-modified motion algorithm called a tracker. That automatically initiates air tracks based on the data received, range and bearing information received from each of the radars or the other sensors. The tracker uses absolute motion over a varying period of time from each of the sensors to determine if the plot has motion that would be consistent of an aircraft's possible motion. It then creates a possible track. If subsequent plots confirm sensible motion, a track based on the plots is created, displayed, and transmitted. The tracks are examined to determine if they are at a proximal location and have the same speed and heading. If the tracks remain in close proximity over time, a software algorithm is applied to determine whether there is one track or multiple tracks positioned very close to each other. In the case of aircraft tracking seen here, if the aircraft friend or foe transponder information data is available, it can be used to assist in determining whether there is one or more aircraft in close proximity. When only the transponder IFF data is available, LifeRing alternatively uses it as the basis to create a track that can be transmitted to the interfaced C4I systems. As mentioned before, when LifeRing is receiving data from sensors that provide only plots, they have to be pre-processed to determine whether they are just noise from the sensor, weather, birds, waves, mountaintops, etc. These plots that are not associated with aircrafts are noted with lowercase letters on the map, not associated with a track symbol. When LifeRing is linked with radar data and other sensors that provide a track, the incoming track is assigned a track number to identify each track from other tracks. If we hook one of the tracks, we see the letter associated with the radar site providing current tracking data. The site identifier or letter representing the radar site fades as more current location data is gathered, which are seen as bolder, darker letters closer to the track symbol. These tracks are then transmitted on Link 16, JVMF, OTH Gold, Cursor on Target, and other appropriate NATO data links.